Adding and subtracting rational functions is actually not that bad. If you remember the steps that we did basically when we did regular fractions, adding them or subtracting them, you'll be okay. Just kind of remember, you have to make the denominators the same. So let's tackle this one right here. X plus 3 and x plus 3, those denominators for this fraction is the same. So if I want to add 2x plus 5 divided by x plus 3 plus negative 7 over x plus 3, I can simply add the numerators. So that would be 2x minus 2. The reason being is because my answer is, I basically take the 5 and the negative 7 and I subtract those, or 5 minus 7. I don't deal with the 2x because I'm not subtracting any x's on the second numerator. And then I keep the same denominator, x plus 3. At this point you can solve this, and basically this is, or you can factor out the 2 and you have x minus 1 over x plus 3. But to be honest with you, that's kind of an extra step because it's not needed. Because it would be cool if I could cancel something out from the top and the bottom, but I can't. So essentially I have to stop there. Now, for this second one, x plus 1 times x minus 2, I'll be honest with you, the denominators are just not the same. So what is the common denominator? Well, it's kind of like the same one when we did 5 over, I think it was, or 1 over 5 plus 3 over 8 or something like that. I forgot. It was up there somewhere. There aren't really any common factors that you can kind of find between them. So basically, I said the common denominator was 40 because I multiplied 5 times 8. Essentially, you're doing the same thing here. My common denominator that I'm going to put both of them over is x plus 1 times x minus 2. There's nothing really in common between them, so I need to basically just multiply them out. Now, in order to, here's my first term, that's the 3 over x plus 1. In order to make that the same denominator, I need to multiply the 3 by x minus 2. Same thing goes, or well, similarly, I want my x plus 1 times x minus 2 as my denominator, and I have an x over here. That's from this second term right here. But in order to make that true, I need to multiply it by x plus 1. Because essentially I'm multiplying this is actually the same as 1, and I'm multiplying this by 1, and this is the same as 1, so I'm multiplying that by 1. I'm not changing the equation, I'm just changing how it looks. Because the point I'm trying to do is get it over a common denominator. Now, since these two things have a common denominator, I can basically add the tops and keep the denominator. X plus 1 times x minus 2. Alright. Now over here, what I'm going to do, well, I guess I'll write it out for you. I'm going to simplify this a little bit by distributing the numerator. I'm going to take the 3 and put them inside of these parentheses and take this x and put them inside. So I end up with 3x minus 6 plus x squared plus x, all divided by x plus 1 and x minus 2. Okay, keep going. I can combine like terms, so I've got x squared plus 4x minus 6 equal, or divided by x plus 1 and x minus 2. Now, if I were to try factoring this thing, and I already can tell you that this thing can't be factored, but if I could factor this, I could further reduce this thing. So I would try to play that game. What I mean by factoring it is try to take that numerator and put them into something like that. I can see from here, just from my math experience, that that can't be done. So at this point I'm done. The only thing I need to mention, I forgot to mention in the previous problem, is that over here x cannot be equal to 3, and also x cannot be equal to -1 and +2 in the second problem over here. Because having x be negative 1 would cause your denominator to be 0, and then you would explode and everyone would die. Let's do this one. I'm not going to talk as much. I'm just going to do it as quickly as possible and talk to myself. I'm going to go x plus 6 times 4x plus 5 plus x times x plus 1. I know you guys are thinking, what is he doing? He's doing it all in his head. Actually, it's not that bad. 4x plus 5. I basically knew that my common denominator was basically those two denominators multiplied to each other. So I asked myself, in the numerator of the first one, what is it missing to make it have that denominator? Well, it's missing a 4x plus 5. And then in the numerator of the second one, it's missing an x plus 1. Now I can distribute this thing out. So this would be foiling this thing on top, first, outer, inner, last. And doing that carefully, that would be 4x squared plus 5x plus 20x plus 30. Alright, so I did that first one. Now I'm going to put a plus sign. That would be this plus sign here. And then I'm going to make this an x squared plus x. I just distributed the top. And then I'm going to divide that whole thing by x plus 1 times 4x plus 5. Alright, let's take the numerator and we'll simplify that a little bit. And then we got, let's see, combined like terms, I've got 5x squared. 5x squared plus 25. No, it would be actually 26x. Because 5 plus 20 plus 1 is 26x plus 30 divided by x plus 1 times 4x plus 5. Let me just double check to see if I made any mistakes, because I could have easily made a mistake. Let's see. First is 4x squared. Outers is 5x. Inners is 24. Because 6 times 4 is 24, not 20. Oops. That would make this thing 30. I guess if you wanted to, you could factor out a 5 out of the numerator, but that wouldn't really help you because you can't factor out a 5 out of the denominator to cancel it subsequently. The excluded values for this thing is x cannot equal negative 1 or x cannot equal negative 5 over 4. Yeah, let's do the subtraction one. Even though I'm running late on time, hey, what the heck? I'll give you extra points just for watching this video. I'm going to do it a little quickly. 9x minus 8 times 2x minus 3x minus 6 times x minus 7. Now, the only thing I would worry about with subtraction is making sure that this negative right here, which is the same as that negative over here, gets distributed to that second term. I'm going to keep this second thing in big parentheses until I distribute that negative in there so I don't forget. In fact, why don't I do this? I'm going to have the x minus 7, I'm going to have the 2x, and I'm going to actually deal with that second thing right there, this guy right here. I'm going to FOIL that out, and that becomes 3x squared. That's the first. Outers is negative 7x, or no, negative 21x. The inners is the negative 6x. And the last is negative 6 times negative 7, which is negative, oh man, I'm really terrible at this, 42? Is it 42? I think so. No, wait. Yeah, 42, I guess. But it's actually positive 42 because it's negative 6 times negative 7. Keep in mind that I have a negative out in front of this big parentheses, which means I'm going to distribute that negative in there But before I do that, let me deal with this first term over here, and that becomes 18x squared, because 9x times 2x is 18x squared, and then minus 16x. Now I'm going to distribute this negative in, so I have 18x squared minus 16x minus 3x squared plus 21x plus 6x minus 42. The reason why I am so careful with this thing, I kept it inside of a parentheses and then distributed that negative, is because I usually make these small sign errors, but I don't want you to make them, so I was just trying to be extra careful with that one. Alright, let's do this one. This becomes x minus 7 times x plus, or times 2x. Combining like terms, that would be 15x squared, because there's 18x minus 3x squared. This one right here would be 11x. Negative 16 plus 21 plus 6. Alright, and then minus 42 divided by x minus 7 and 2x. Now, can I cancel out a 2? No, because there's not a common 2 in the numerator. Can I cancel out an x? No, I can't pull out an x out of the numerator. I guess what I could do is I could check to see if x minus 7 can nicely divide into this thing. But at this point, I'm kind of lazy, and I'll just say, you know what, that's my answer. By the way, x cannot equal to 7, and I'm excluding x equal to 0. Because if I plug in x equals 0, it doesn't matter what, the numerator will be negative 42, but the denominator will be 0, and that's a big problem too.